Right at the next chapter heading. Nuclei. Atom is over. Nuclei, right? Nuclei. Spelling data. சொல்லுங்க கரெக்டா தப்பா? சிங்கிள் ஐ இல்ல டபுள் ஐ தான். சிங்கிள் ஐ வரும்போது ஒரு நியூக்ளியஸ் எல்லாம் பண்ணி டபுள் ஐனா ப்ளூரல் ஃபார்ம் ആണ് ന്യൂക്ലിയേ. സോ കറക്റ്റ് ഓൺലി ന്യൂക്ലിയേ. ഓക്കെ ഓക്കെ ഈ ചാപ്റ്ററിൽ നിന്ന് വരുന്നത് ഒരു ക്വസ്റ്റ്യൻ. ഓക്കെ അതുക്ക് മേലെ കേൾക്കാതെ അതുക്ക് ലെസൺ കേൾക്കാതെ ഒരു ക്വസ്റ്റ്യൻസ് ഡെഫിനറ്റ്ലി വിൽ കം ഫ്രം ദിസ് ചാപ്റ്റർ. ഓക്കെ അത് ആറ്റംസ് ഒന്നും ആറ്റംസ് ഒന്നും അതുമാതിരി தான், ന്യൂക്ലിയസ് ഒന്നും അതുമാതിരി தான். ആറ്റം ന്യൂക്ലിയേ. Dual nature of matter and radiation. Modern physics il 4 chapters. Okay. Dual nature of matter and radiations nu 2 question. Semiconductor nu 2 questions. Atom 1 question. Nuclei 1 question. ഇതാണ് ഇതിന്റെ പാറ്റേൺ. ഓക്കെ അങ്ങനെ ടോട്ടലി 2 + 2 4 + 2 6 questions. ടോട്ടലി മോഡേൺ ഫിസിക്സ് എന്നുള്ള ഏരിയയിൽ. ഓക്കെ അതിൽ ഈ ഡ്യുവൽ നാച്ചർ ഓഫ് മാറ്റർ ആൻഡ് റേഡിയേഷൻ ചാപ്റ്റർ ഐ തിങ്ക് യു ആർ അറ്റൻഡിങ് ഓൺലൈൻ. സ്റ്റാർട്ടഡാ? No, okay, it will come when the recording is over. So adil oru de Broglie wavelength undu. So definitely that area one question will come every year. It's common till last year also. So you will see that. Okay, that is easy. Atom is already over. Okay, now next one is nuclei. Here this chapter will contains a very less numericals. Sums ഭയങ്കര കമ്മി. ഓക്കെ ഇറ്റ്സ് വെരി ലെസ്. അതായത് ദർ ആർ നോട്ട് മെനി തിങ്സ് ടു വർക്ക് ഔട്ട്. വെരി സിമ്പിൾ ആണ്. ബട്ട് തിയറിറ്റിക്കൽ ക്വസ്റ്റ്യൻസ് ആർ ദർ. ലോട്ട് ഓഫ് തിങ്സ് വിൽ ബി ദർ. Okay, so one thing what you have to do means we will write lots of notes of course in this chapter, but additionally read NCERT book also, because in case if I missed something or 0.1% miss ana, there is a chance to ask. Okay, NCERT book, biology book read and adhe marida. I know your physics book is very fresh. Correct? Normally ഭയങ്കര ഫ്രഷാக இருக்கும் கம்பேரிட்டிவ் டு யுவர் பயாலஜி. பயாலஜி அப்படியே அதை யூஸ் பண்ணதே தெரியும். ஃபிசிக்ஸ் வச்சுன்னா அது வாங்கினப்படி அதே மாதிரி இருக்கும். கெமிஸ்ட்ரி மோரோல சேமாக இருக்கும். கொஞ்சம் ஒன்று இதாக இருக்கும் கம்பேரபிள் டு ஃபிசிக்ஸ். பயங்கர ஃப்ரெஷ்ஷாக இருக்கும். அப்போ ഈ ചാപ്റ്റർക്ക് okay, every chapter I will not tell you. Two chapters second year you have to read. One is electromagnetic waves, which we are going to take. Okay, one is this atoms and nuclei. Okay, class note படிச்சதுக்கு அப்புறம் you just try to read that, you will understand. Okay, அது எதுக்கு சொல்லுங்கட்டேன்னா small points இருக்கும். Okay, ஒரு பாயிண்ட் மிஸ் ஆயினா ആ பாயிண்ட் क्वेश्चंस வரீங்களா வராதான் we cannot tell you. ஓகே அப்போ அந்த லைனில் வேர்டு பை வேர்டு படிக்கிற மாதிரி இருக்கும். அதே மாதிரி தான் நோட்ஸ் எழுதும்போது நிறைய பாயிண்ட்ஸ் இருக்கும். ஆ பாயிண்ட்ஸ் ആണ് we should not miss one points. കാരണം lot of theory. മറ്റേ മെക്കാനിക്സ് എല്ലാം പഠിക്കുമ്പോൾ there are lot of diagrams, concepts, optics എല്ലാം மாதிரி അതே மாதிரி தான் நிறைய கான்செப்ட்ஸ் வருது. கான்செப்ட்ஸ் எழுதினா அது கொஸ்டின்ஸ் எப்படி கேட்டாலும் we can able to answer, but here lot of theoretical steps will be there. Okay, so let's start. Write the heading called the nuclei. First one is first subheading nuclear structure. Nuclear structure, many things you know of course from small classes onwards, but something you may not know, but we'll see. Okay, what is the nuclear structure? Center atoms, correct? ഒരു ആറ്റത്തിന്റെ സെന്ററിൽ ഇരിക്കുന്ന ഏരിയ we are going to study. Okay, ഒരു nucleus, this is called nucleus. This already you know. Nucleus consists of what? Protons plus neutron, and the sum of proton plus neutron is called mass number. Correct? Here in this chapter mass number we are representing using a letter called A. A is called mass number. Come, A is called mass number. Okay, that is the first point. Second point, I will give you the notes. You can just listen now. Anyway, we have many things to write. Okay, many things you know, but so nucleus is center which consists of proton plus neutron, and the sum of proton plus neutron is called atomic mass or mass number. Okay, mass number. Next one, the center consists of this proton and neutron. This together is called one word. This may be a new to you. This is called nucleons. Okay, nucleons. So nucleons means either it is proton or it is neutron or some of these two. So nucleo means the particles which are within the nucleus. Nucleus kulla irukana particles is called nucleons. Okay, and what is the mass of proton? 1.67 into 10 power minus 27 kilogram. This is called 1 AMU, atomic mass unit. Okay, this value is called 1 AMU. So if you want to convert AMU into kilogram, you have to multiply with this number. Okay, this we will see while we are doing the problems. Okay, what is the charge of proton? Plus 1.6 into 10 power minus 19 coulomb, and what is the charge of neutron is equal to 0 coulomb. Okay, and the sum of number of masses, for example, if this contains 2 proton, if this contains 2 neutron, then what is the mass number of this one? 4 is the mass number. Okay, mass number is normally representing in terms of AMU, atomic mass unit. So 4 AMU is equal to 4 into 1.67 into 10. This is the mass of the nucleus. Okay, straight away you are adding, you will get AMU. You multiply it with 1.67 into 10 power minus 27 kilogram, you will get in kilogram. Okay, depends upon the question. Sometimes in question everything will be in AMU unit, so you can answer it in AMU. But sometimes question is in kilogram and mix of AMU, then you have to convert either into AMU or into kilogram. Any one you have to follow. Come. Okay, so we'll write some points, notes, right? Nucleus consists of neutrons and protons. Nucleus consists of neutrons and one point miss because theory is very important here. Nucleus consists of neutrons and protons. Neutrons will have 0 coulomb charge. Neutrons will have, next point, neutrons will have 0 coulomb charge and proton will have a charge of 1 plus 1.6 into 10 power minus 19 coulomb. Okay. Next one. Total mass of proton plus total mass of neutron is called mass of the nucleus. Total mass of proton plus total mass of neutron is equal to mass of the nucleus. Next one. Approximate radius of the nucleus is equal to 10 minus 10 meter. Sorry, 10 power minus 15 meter. 10 power minus 15 meter. Okay, then write the next point. Number, subhead, atomic number. Atomic number. Atomic number means what? Atomic number means what? Proton or electron. That is called atomic number. Okay. Below, right? For an atom, ZXA. For an atom, ZXA. Z is called atomic number. Z is called atomic number, which is equal to number of proton is equal to number of electrons. Both are same, right? Atomic number bracket Z is a letter we are using all over here. Okay, next one, mass number, capital A. Next point, mass number, capital A. Below, right? Number of proton plus number of neutron. Number of proton plus number of neutron is equal to sum of all nuclei. Sum of all nuclei. Sum of all nuclei. Okay. Next heading, classification of nuclei. Classification of nuclei. These things also you have learned in chemistry also. Isotope, isotons, isobar, then that's all, 3. So first 3 will be here. First one, isotope. First one, isotope. Isotope means what? Same atomic number, different mass number. Okay. So isotope, it's a group of elements. It's a group of elements having. It's a group of elements having same atomic number. It's a group of elements having same atomic number but different mass number. Example, 1H1, 1H2. 1H1 is called 1H2 is called 1H3 is called tritium is also called. Okay, so 1H1, 1H2, 1H3. One atomic number same, mass number is different. That's called isotope. Next one, isotons. Isotons. Isotons means what? Group of elements having isotons. Same neutron. Group of elements having same number of neutrons. See here, atomic number 3, lithium, 7, mass number. Beryllium, atomic number 4, mass number 8. How to find the number of neutrons? 7. Atomic number minus this number of proton, right? This is the number of protons. Number of protons. This is the number of proton plus number of neutron. Okay, so how to find out number of neutron? Number of neutron is equal to this 7 minus 3. Come, 7 minus 3, which is 4. Okay, beryllium also 8 minus 4 is equal to 4. Same number of neutrons. This is called atomic number, correct? Next one, idellam chemistry la padikkunna. That is nothing big changes. Isobar. Isobar. Next one is isobar. Isobar means what? Having same mass number but different. So group of elements having same mass number but different atomic number. Helium 2He4. Can you tell me one for same mass number? Carbon. Different mass number, same atomic number. 2 second group elements. Boron, aluminum, gallium, indium, thallium. Where are you? Calcium atomic number 20, mass number 40. This equal calcium argon. Calcium argon atomic number 18. Okay, mass number 40. But but ഇത് ഈക്വൽ ആവണ്ടടാ. ആൽഗിറാണ്. ഓക്കെ, ഹീലിയം അല്ലാതെ. ഓക്കെ, സോ താങ്ക്സ്. ഓക്കെ, ദിസ് ഈസ് 40, ദിസ് ഈസ് 40. കാൽസ്യത്തിൻ്റെ അറ്റോമിക് നമ്പർ 20, ഇത് 18. ഓക്കെ, കാൽസ്യം and argon. Okay, so 3 things: isotope, isotone and isobar. Okay, complete periodic table. You know how many elements will be there? 150 na 120 now more than 115, right? 118, 118. You know everything, S, P, D, F, lanthanides, catenides. There is some shortcut will be there to learn, right? Some code which I don't know, I forgot. 2016. Okay. Okay, so next heading: shape, size and density of nucleus. Shape, size and density of nucleus. Shape, size and density of nucleus. Below right, shape of the nucleus. Shape of the nucleus is considered to be spherical. Is considered to be spherical. With a deviation of less than or equal to 10%. Less than or equal to 10%. What is the meaning of that one? Normally, the shape of the nucleus: shape, size, density. 3 things we are going to see for a nucleus. For a nucleus. So shape is defined as, shape is what form? Spherical structure, correct? Spherical with a deviation of how much is a deviation, sir? What is the meaning of that one? With a deviation of less than or equal to 10%. What is the deviation? This is correct circle, I am assuming. I know it's not a correct circle. Deviation means this structure with small deviations I can expect. Okay, this is a perfect circle. For example, 100% with from here to here radius r, from here to here radius r, from here to here radius r. Deviation means if this radius is 100, 10% deviation means less than 10% means how much I can go up to? Maximum 90. Maximum 90. Okay, I cannot go to 80 because 10% coming, that is called 90%. So up to this way the nucleus structure can vary, then with a deviation of 10% in the meaning. Okay, understood. Next one: radius of or size of the nucleus. Radius or size of the nucleus. Below right, volume of the nucleus. Volume of the nucleus. Volume is directly proportional to volume, and the size is directly proportional to what? Mass number. Okay, more number of nucleons means more number of volumes. Okay, so V is proportional to A. What is volume? 4/3 pi r cube is proportional to A. 4/3 pi r cube is proportional to A, where capital R is the radius of the nuclei. Where capital R is the radius of the nuclei. Okay, then we can write R cube is proportional to A. R cube is proportional to A. R is proportional to A raised to 1/3. Katala. A raised to 1/3. Next, proportionality sign replaced with a constant which is called R0. R0 into A power 1/3. R0 is a constant and its value is equal to 1.2 fermi meter. Okay, means how much? 1.2 into 10 power of minus 15 meter. This is important. Many places we will use this one. Okay. Next one, density. Next one, shape is density. Density is rho equal to, in nuclei, density is equal to A divided by V. A is 1 AMU. For example, if A is 1 AMU and volume is 4 by 3 pi r cube. So we can put it like this. A divided by 4 by 3 pi r cube. So A divided by 4 by 3 pi into, what is r cube? R0 raised to, R0 into A power 1 by 3 whole cube. So A divided by, simplifications, 4 by 3 pi into R0 cube into A get cancels. So rho equal to 1 divided by 4 by 3 pi R0 cube, which means that what? Which means density, rho is independent of, very important point, density is independent of a mass number. Density is independent of mass number. Okay, so write the next heading, radioactivity. Write the next heading, radioactivity. Radioactivity means what? Last class I told, every atom or every element, whether it's living or non-living organisms, whatever, so everybody would like to achieve what called stability. First upon example I told, right? We will find seeds first to achieve stability. There are a lot of elements in the nature, in your periodic table itself, which are unstable. Example for an unstable element? A simple example, uranium. Uranium is purely unstable. Okay, so there are a lot of unstable elements will be there. These unstable elements will try to come to stable position. How they'll come to stable positions? They will emit radiations in a simple way. They will emit radiation, and these type of elements are called radioactive elements. So radioactive elements is always try to come to stability by emitting the radiations. That's radioactivity. Radioactivity means what? A reaction. Activity means some process. Radio means what? Radiations. So radiation process. That's radioactivity. Term radio plus activity. Radiation activity. Radiation activity means radiations are going out. Okay, that's a word meaning itself. Activity means any activity. We'll say physical activity. We are workouting. We are going for jogging. All these are called activities. Okay, that are not related to physical activity. Similarly, here activity with respect to radiation means radioactivity, which means an atom which is completely unstable, not stable. Stable positions. So what that atom will do? That atom will try to emit radiations. Our radiations different formula, alpha radiations, beta radiations, gamma, positron, anti-neutrino, neutrino, many things will be there. That we'll see later. But right, the next the one point will be there. Radioactivity means an atom which is in an unstable position, an atom in an unstable position try to come to stable position. An atom in an unstable position try to come to a stable position by emitting the radiations. by emitting radiations. This process is called, this activity is called radioactivity. This activity or this process is called radioactivity. Radioactivity is discovered by Henry Becquerel in 1896. Henry Becquerel 1896. Next heading, stability belt. Subheading, stability belt. Draw this graph, then we'll see number of neutrons. Simple only, there is no complicated things. Number of proton. Completed? Okay, simple ആണ്. Number of neutron plus number of proton ഒരു graph. Okay, this is the elements. Come. This is the elements in your periodic table. Okay, you told right 118 elements are there. Yeah? So in this 118 elements we have plotted number of proton versus number of neutron. So before plotting we have taken one line. This is n is equal to z, which means number of neutron is equal to proton. Proton means atomic number. So this is a line. Okay, and what we have seen is like there is something called a stability belt. Stability belt is a line in which we have drawn where you can see lot of dots will be there. So there are certain elements which are falling above this line. This is just a line, nothing else. There are elements, these every dot is indicating one element. There are elements which are above the stability belt, and these elements are a radioactive element which is an unstable element, and these elements will come to stable position by emitting beta minus radiation. There are two things will be there, beta plus und, beta minus und. Okay, normally we'll say beta. I'll tell you what is that later. Okay, so the elements which are emitting radiations above the stability belt and come to stable position by emitting beta minus radiation. Some elements which are below stability belt which are also unstable, and those are emitting beta plus and alpha emission to become stable. So stability belt is a middle line actually. So above there are unstable elements, below there are unstable elements. These elements will come to stability by emitting beta minus. These elements will come to by emitting beta plus and alpha emissions. Okay, this is just a plot, that is just to understand where each elements in your periodic table is comes, where there it is, or here or there. So somewhere all these elements will fall. So the elements which are mostly stable kind of nature will come to the down stage, very down level. Okay, so we'll write some points below. Write some point. Nucleus lies exactly on the stability belt. Nuclei lies exactly on the stability belt, are very stable, are very stable. Normally for an elements whose atomic number less than or equal to 20 are stable. Atomic number less than or equal to 20 are stable. Example: 6 carbon 12 magnesiums 24. These are called the stable nucleus. Also some elements having n by p, number of neutron divided by number of proton is approximately equal to 1, are also stable. For example, in the above example, 6 carbon 12, number of neutron is equal to how much? 12 minus 6, number of neutron, 12 minus 6, 6. Number of proton is equal to 6. So n by p is equal to 1. So it is stable. Okay, this is stable. Next point. For nuclei whose atomic number is greater than or equal to 20, whose atomic number greater than or equal to 20 are also stable only if it satisfies the following condition: 1 less than or equal to n by p less than or equal to 1.6. 1 less than or equal to n by p less than or equal to 1.6. The nuclei, next point, the nuclei falls above and below the stability belt are emitting alpha, beta plus, beta minus radiations. All these unstable elements emit gamma radiation as well. Radioactive decay means what? Emitting the radiation. Radioactive decay or the disintegration process. Radioactive decay or the disintegration process is a spontaneous is a spontaneous or random process. Is a spontaneous or random process. Next heading, alpha decay. Alpha decay. Write the first point. If an element emit an alpha particle, then its mass number reduces by 4. Then its mass number reduces by 4 and atomic number reduces by 2. Then its mass number reduces by 4 and atomic number reduces by 2. Write the example in the board. Next, energy released, bracket heat energy is given by E is equal to delta mc square. Einstein mass energy relationship, right? What Einstein is told, mass can be converted into energy. Okay, so delta mc square. What is delta m will be here means this is a mass of y and this is mass of alpha particle and this is mass of x particle. So what this indicate means mass of x minus mass of y plus mass of alpha. That difference is called delta m into c square. This is normally in AM, normally the masses, which means mx, my and m alpha in AMU. Normally mx, m alpha in AMU. Energy in joule is equal to mx minus, how to convert mass into kilogram from AMU? 1.6. So we'll multiply it with, okay, then mass kilogram to convert here. Suppose okay, we can write 1.6 into 10. This mass in a kilogram to convert it. E case mx, my and m alpha in kilogram to convert it. Next, one more point. That depends upon the question we have to use. Energy in mega electron volt. E is equal to mx minus my plus m alpha into c square. So here mx, my, m alpha all in AMU. You have to take all in AMU and multiplied with 931. Then your unit will be in mega electron. You have to multiply it with 931. Exactly 931.5. 931.5 mega electron volt. So depends on the question. That's all. Next step. Momentum is conserved. Next point. Momentum is conserved. Next one. Momentum is conserved. Momentum is conserved. Full stop, then right. In a radioactive decay process. In a radioactive decay process. In a radioactive decay process, momentum is conserved. Momentum is conserved. That is the example. X is a radioactive element. Okay, so the velocity of X. So right, the velocity of X is equal to what? X is not moving. X is initially at rest. X is equal. Then it is disintegrated. Then how many particles will be there? 2 particles. One is this alpha and one is this y. Both are moving with a certain velocity. So right, the velocity of X is equal to 0 and velocity of y equal to Vy and velocity of equal to V alpha. So what is the momentum conservation? Initial momentum is equal to final momentum. So Pi equal to Pf. Momentum conservation. Initial momentum is equal to the final momentum. So Pi equal to Pf. So Pi equal to Pf. Initial momentum mx Vx is equal to final momentum my Vy plus m alpha V alpha. This is 0 is equal to my Vy plus m alpha V alpha, which means my Vy is equal to m alpha V alpha in magnitude wise. Correct? If you are not writing in a magnitude wise, how will get? You know, m by Vy equal to minus of m alpha V alpha. What is the meaning of this one? This means the Y atom is moving in this direction, then the helium is moving in opposite direction. That's the meaning of this one. Okay, if it is comes with a negative sign, that is the meaning of that one. Next one, kinetic energy of the emitted alpha particles. Next point, kinetic energy of the emitted alpha particles. Total energy released in the process. Total energy released in the process. In terms of kinetic energy. In terms of kinetic energy, Q is equal to total energy is heat energy. Q is equal to kinetic energy of alpha plus kinetic energy of the element Y. Kinetic energy of alpha plus kinetic energy of Y. Okay, what is the kinetic energy equation? Which kinetic energy equation will use? We have half mv square. That we cannot use it here. Will be here because the momentum is conserved, means we'll use p square by 2m. One equation will be there, p square by 2m, m for alpha plus p square divided by 2m for y. So these equations we will use it. Remember, kinetic energy do not go for half mv square because the momentum is conserved. Momentum and p square. Understood? Then the next point. this we will simplify it a little bit. Q is equal to, and we can rearrange it and we can simplify and we can find out. Simplify just if you want, we can just keep it. That's all. Or you can keep it like this one. That is also fine. If you want, we can also simplify. This 2 is taken left hand side. So 2Q is equal to P square by M alpha plus P square by M y. So 2Q into P square 1 by M alpha plus 1 divided by My. You don't want to remember, this is also enough to do. Then another format, just another format only. Q is equal to 2Q equal to P square into M alpha plus My divided by M alpha into My. What will get it from P square from the P square is equal to 2Q into M alpha My whole divided by M alpha plus My. Now kinetic energy of alpha particle is equal to P square divided by 2M alpha. That was a heading. So 2Q into M alpha My whole divided by 2 into M alpha plus My into M alpha. So M alpha got cancels. So we got 2Q My into 2 also got cancelled, right? So Q My divided by M alpha plus My. This is the kinetic energy of alpha particles. What is KEY will come? Reverse KEY. KEY what will come? Tell me, Aishwarya, KEY means what? Q into M alpha divided by M alpha plus My. Just a reverse. Numerator mattum change. Next heading, beta decay. Beta decays are two types. 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 Beta minus decay. Beta decays are two types. Beta minus decay and beta plus decay. Below right. In beta minus decay, atomic number increases by 1. Atomic number increases by 1 and anti-neutrino is produced. Anti-neutrino is produced. Is that XA element if emitting a beta minus means minus 1 beta minus 1 beta plus the element which is coming Y. Atomic number increases by 1, mass number 1 change plus new bar. Okay, so this can be written as in this term also in some textbook, beta minus decay, and this is an extra element emitting and this is called anti-neutrino. Anti-neutrino ഈ gamma rays the beta minus decay kuda vele varnada, that is called anti-neutrino. This can be represented like this or like this. Both are called beta minus decay. Okay, next one, beta plus decay. Beta plus decay, now you know well than me. In beta plus decay, what will happen to the atom? Decreases by 1. Yes, in beta plus decay, atomic number decreases by 1. So which means if you have ZXA, then you have to write plus 1 beta and plus Z minus 1 YA plus nu. Nu is called neutrino. This is called neutrino. Beta plus neutrino, beta minus anti-neutrino. Below write, just write a note. In numerical questions, if question is given as beta decay, then by default beta minus decay is considered. Beta minus decay is considered. Below write some additional points. Beta minus decay is actually a conversion of neutron into proton. Beta minus decay is actually a conversion of neutron into proton. Write this one, 0n1 1p1 minus 1e0 means this is equal to what? This is equal to beta minus, or this is equal to minus 1 beta. All are same. It is actually neutron into proton. Next point, the electrons emitted, this electron emitted is created inside the nucleus at the time of emission only. These all from NCERT sentence only. At the time of emission only. This is just like a photon is emitted. Okay. So what we have written? These steps. Okay. So the radioactive decay is what kind of process? It's a random process. Radioactive decay is a random process. Random process a number of nucleons are reducing. Okay. If initially 100 nucleons disintegrate final the number will be very less. Okay. So dn divided by dt means what? Rate of changes. Time is changing, the count is changing from where? N0 to N. N0 is the initial number, N is the final number. Whenever it is N0, the time is equal to 0, and whenever it is N, the time is equal to T. And dN by dt, the proportionality sign is replaced with a constant called lambda. Lambda is called two names, disintegration constant or decay constant. Then what we have integrated. Okay, integration. N terms separated and T terms separated. Integrated, we got log N and lambda into T. Upper limit minus log a minus log b, log of a by is equal to minus lambda t. Log is taken to the right hand side, it become exponential. So n divided by n0 into e power minus lambda t. Okay, here this equation is called law of radioactivity. This is the base equation. From this base equation we are just integrated and we solve it. Finally we got n is equal to n0 into e raised to minus lambda t. What is called n? Number of nucleons remains. What is there? N0 is the initial number. T is the total time reaches from n0 to n. N0 to n. How much time is taken? That time is called t. Clear? Hope it was clear. Okay. Then next one. Definition of disintegration constant. Radioactivity. Next subheading. Definition of disintegration constant, which means definition of what? Lambda. Definition of lambda. Definition of lambda. Lambda is the definition. Okay, what is the definition of lambda? We equal to n0 into e power minus lambda t. Let me take lambda is equal to 1 by t. Then can you substitute and will happen? We'll see what is happening here. What will happen? If lambda is equal to 1 by t, then what will come? Right? N equal to n0 into e power minus lambda 1 by t into t. So n equal to n0 into e power minus 1, which means n equal to n0 divided by e. 1 by e 0.36 on. So 0.36 n0, which means that what? N is the final count. N0 is the initial count. Initial count is multiplied with 0.36. I can say 1.36 means 36 into 100. What is that? 36% of N0 is equal to N. Okay. So which means 36% of N0 remains. N0 remains. So how much is already disintegrated? 63%. 36.66 value. So 63.33% disintegrated. Disintegrated means it's destroyed. Okay. So lambda is defined as 1 by time period. Okay, so lambda is the 1 by time provided during this condition. So definition of lambda is equal to 1 by t. When lambda is equal to 1 by t, 36% of n0 remains there, which means 63.33% nucleons are disintegrated, which means it's not there. That is the definition of lambda. Lambda is equal to 1 by t. That's the meaning. Which means that what? 1 by t is the time, right? Suppose I'm assuming, for example, t is equal to, listen here, t is equal to 4 seconds. Okay. Earlier t is equal to 0 second, 100 nucleons are there. When t is equal to 4 second time, now I have 36, which means how much is disintegrated? 63.33% disintegrated, 36.6% remains. In how much time this is happened? 4 seconds this one. Then what is the value of lambda? 1 by 4. 1 by 4 means this is a concept. Okay, 36.6% how much time it is taken? Time in the local inverse on lambda. Lambda is called the disintegration constant. Next one, graphical representation of next heading. Graphical representation of variation of T. Graphical representation of variation of n versus t. N versus t. n equal to n0 into e power minus lambda t. Appa n with t, this relation is what? E power, that's the relation. Yeah. E power minus lambda t, n equal to. So n with the t graph, proportional t, I can say, for example, lambda is a constant, so e power minus. So this is an exponential graph. Exponential graph means minus 1, that is called exponentially decaying graph. Exponentially decaying graph. So n versus t, ഇതാണ് exponentially. ഇത് പ്ലസ് ആയിരുന്ന റൈസിംഗ് ഗ്രാഫ് ആയിരിക്കും. കപ്പാസിറ്റൻസ് ചാർജിങ് ഗ്രാഫ്, ഇറ്റ്സ് ലൈക്ക് ദാറ്റ്. Okay, exponentially decay graph. With n with t, similarly, log of n0 plus or minus lambda t. So log n with t graph, it's a straight line equation. So how the graph will look like? This can be connected with a relation y is equal to mx plus c. So y is equal to, what is m will be here? Minus lambda t. Okay, minus lambda t plus log of n0. So decaying graph. Y intercept is what? This is a y intercept. Y intercept is what? Log n0. So it's coming from here and going like this. And this intercept is called log e n0. And slope of the graph is equal to good. Lambda means minus lambda. Negative slope, right? Coming down. Negative slope. Next one, next heading. Power released in a radioactive process. Power released in a radioactive process. Power released in a radioactive process. Okay. Let E be the energy. Let E be the energy released in the radioactive process. Let E be the energy released. Let E be the energy released in a radioactive process. In a radioactive process. Okay. Power equal to P into E by T. NE by T. Energy by time, of course you know, it's called power, right? E by T. N is the number of nucleons. Number of nucleons. N is the number of nucleons. Next one, next heading. Half-life. Half-life. Life. What is called half-life? The equation. Half-life means n become n0 by 2. Okay, n become n0 by 2. Then initial count in a half in a time, that is called half-life. So half-life is defined as the below, right? Half-life is defined the time taken by a radioactive substances. Time taken by the radioactive substances to reach half of their initial count. to reach half of their initial count. So to reach half of their initial count, what is the time taken by the radioactive substance? And that is called a half-life. So we know the equations, right? What are the equations? N equal to N0 at T. Now N become N0 by 2. This is given as 0. Okay, N0 get cancels. So it becomes 2 equal to essentially to this side as log. So log E 1 by 2 is equal to minus lambda T half. Okay. So log of 1 minus log E, all are base E, 2 is equal to minus lambda T half. What is log 1 to the base E? 0 minus, what's the value of this one? Let me keep it like this one. We will replace it later. 2 is equal to minus lambda T half. So T half is equal to log E, log 2 the base E divided by lambda, which is equal to 0.69 divided by lambda. This is called the half-life period. Time taken to reach 50% of its value. Next, write a note. Write a note. N0 to N0 by 2. How many half-life? Okay. N0 by 2. N0 divided by 4. Or I can say N0 by, correct, N0 by 2, N0 by 2 to the next half-life. Correct, second half-life. Similarly, N0 by 4 on now. It's converted into N0 by 8. Then another half. How many half-life? 1 T half. Okay. Or in a cross way I am saying. N0 to N0 by 8 are how many half-life? 3 half-life. Okay. Which means I am writing N0 to N0 by 8. 3 T half. 3 half-life. Correct alla? Half-life is just half of the initial count. That is called half-life. Next. So N0 to N0 by 8 are the 3 half-life. Which means in general N0 to N0 raised to 2 power N. 2 power N means here 2 power 3. So how much half-life? N T half. Very, very important. Number of half-life. Can we write one question and then see? Okay. So write one question. At a time t equal to 0, write a question. At a time t is equal to 0. At a time t is equal to 0, number of nuclei of a radioactive substance. Number of nuclei of a radioactive substance is equal to 100. Is equal to 100. At t is equal to 1 second, at t is equal to 1 second, these number become 90. 90. Find the number of nuclei. Find the number of nuclei at a time t is equal to 2 seconds. Find the number of nuclei at a time t is equal to 2 seconds. T is equal to 0 is 100 number. T seconds 1 is 90. But t is equal to 2 is 80 വരാതെ 100%. അവരുടെ ഓപ്ഷനിൽ ഉണ്ടാവും. Okay. They have to find some brilliant guys, right? So they will do some brilliant job. Okay. So first case, first equations. N equal to first case. N0, you just write the equation e power minus lambda into t. T is what? First case 0. So n become n0, which is equal to 100. Number 1 equation. 3 equations, that's all. Second one, n equal to n0 e power minus lambda into t. T is how much? 1 second one. During the time, what is the number of called nm? N is 90. 90 equal to n0 into e power minus lambda. Correct? But n0 I know. So 90 is equal to 100 into e power minus lambda, or e power minus lambda equal to 9 by 10. I put it as equation number 2. Okay, here what I can find from this equation number 2? Lambda I can find, right? This term I taken to the right hand side. So it become minus lambda equal to log to the base e 9 by 10. So log 9 to the base e minus log 10 to the base e. Simplify now. Tell me. Three square minus 1. Or I will do one thing. I'll like this one. I'll third conditions. What are the third conditions? N equal to n0 into e power minus lambda into 2. So I'm taking log will be here. So log of n by n e raised to minus, not e raised to, minus 2 lambda. So log of n raised to 100. Katala. Lambda is what? Again I have something. Log e to the base 9, log e to the base 10. This number n has to find out. So equal to minus 2 log e 9 minus log e 10 e 100. How to solve this one? You You want to know the values, right? This is square, 9 by 2 square. That also we can solve it. Here, right? One step here, e raised to minus lambda is 10. Here e power minus 2 lambda. So this can be written as n equal to 100 into e power minus lambda 9 by 10. So 9 by 10 is the square on. So extra how much will come? 2. So it become 100 into 81 by 100. Answer is 81. So you step so here itself we can answer, right? So at 2 seconds 81. Okay. Next question. Next one. Number of nuclei. The next question. This understood, boys? Aslam.
Yes, sir.
Number of nuclei of a radioactive substances. Number of nuclei of a radioactive substances decreases from 8,000 to 1,000 in 9 days. In 9 days. And radioactive substances decreases from 8,000 to 1,000 in 9 days. Find T half and lambda. Find T half. 8,000 to 1,000 reduced in 9 days. Find the half-life and the decay constant. How to do this one? 8,000 to 1,000. So which means 8,000 to 4,000, then it become 2,000, then it become 1,000. So totally this is one half-life, this is another half-life, this is another half-life. So I know totally 3 half-life here. 3 half-life will be equal to 9 days. So one half-life will be equal to 9 by 3 days. So 3 half-life it is taken. Next one, what I need to find out? Decay constant. So T half will be equal to 0.693 divided by lambda. Okay, decay constant. So lambda equal to what? 0.693 divided by T half. T half in a value will substitute will be there. Then we'll got it. 0.693 divided by half-life. T half in a value 3. Upon 2 lambda is equal to 0.231. 0.231. Next heading, activity active substance, activity of a radioactive substances, activity of a radioactive substance, radioactive substance. Again write a note, first point. Rate of decay, not rate of decay, activity is equal to rate of decay. Activity in a meaning, activity means rate of decay. Activity means rate of decay, which is equal to rate of disintegration. Rate of disintegration, which is equal to number of nuclei disintegrating per unit time. activity R equal to minus dn by dt. Important. Minus dn by dt. Activity based questions will be there. Dn by dt. R equal to, what is dn by dt? Minus dn by dt is what? Lambda n. This is comes from where, which equations? Law of radioactivity. Law of radioactivity is in the formats. What we have deriving will be here. What is n? N equal to n0 into e power minus lambda t. So we'll find simple only lambda into n0 into e power minus lambda t. Lambda into n0 is called r0, this one, e power minus lambda t. The activity, there is no much differences. Run the graph. One graph R with T. One graph R with T. How should come? Decreases. Same way like the previous one, right? Decreases. Next one. Log R with T. How it should come? Line. Slope equal to intercept equal to log of R0. Okay, so let's write unit of radioactivity. Unit of radioactivity. Unit of radioactivity. 3 units will be there. Number 1, becquerel. Becquerel, BQ. Unit of radioactivity. So 1 becquerel equal to 1 disintegration. 1 disintegration second. 1 disintegrations per second. 1 becquerel equal to 1 disintegration per second. Standard unit is also called a disintegration per second. So unit ana 3 units. One is called becquerel. 1 becquerel equal to 1 disintegration. The second unit is called disintegration per second. This is a standard unit. Either it is given as becquerel, then 1 becquerel equal to 1 disintegration per second. Third one is called curie. 1 curie, C1 curie is equal to 3.7 into 10 power 10 disintegration per second. Depends upon the question, you have to use the right one. Okay, always take disintegration per second. This disintegration per second in a short form question DPS. DPS. Okay, or just they say D, just small letter D. D means disintegration per second, or it's called DPS. All are same. Okay, depends upon the question, we have to use whatever it is. So write one question. A radioactive substances contains contains 10 power 15 atoms and has an activity of 6 into 10 power 11 BQ and has an activity of 6 into 10 power 11 BQ. What is the half-life? What is the half-life? How many equations we have learned for R? R equal to minus dn by dt, or r equal to lambda n or r equal to r0 into e power minus lambda t. Okay, these three equations you have to remember with respect to question related to activity. So which one we have to use? Rate of change is not given, lambda. Okay, if I get lambda, I can find what? Half-life, t half I can find. So rate is given, so I'll use this one. You have to pick the right equation based upon your context. Okay, so r the value how much? R is the decay, disintegration. How disintegrations? Activity 6 into 10 power 11 is in the standard unit. Yes, becquerel standard unit. So becquerel is equal to lambda into how many atoms will be now contained? Radioactive substance contain how many atoms? 10 power 15. Now it's contained 10 power 15 atoms. Okay, so lambda 4. Now I got half-life. T half is the thing which we need to find out. So T half is equal to how much? 0.693 divided by lambda. So 0.693 divided by 6 into 10 power minus 4. Whatever, so you can simplify. Activity related question, you have to use any three equations. Depends upon the context. Clear? You can write up to this. If you want, you can solve it, else this is okay. Next question. Right. Activity of a radioactive material. Activity of a radioactive material drops to 1/16th of its initial value. Activity drops to 1/16th of its initial value in 24 hours. In 24 hours, the half-life and decay constants are dash. What is given? What is the initial count? If initial count x or initial count taken as n0, 1/16th. So n0 first become n0 by 2, then become n0 by 4, 0 by 8, then become how many half-life? 1 half-life, 4 half-life. So 4 half-life, how much time? 24 hours. How much hours? 6 hours. So half-life is equal to 6 hours. Correct? Then what we need to find out next? Decay constant. So lambda with the half-life relation what? 0.693 divided by T half. 0.693 divided by 6. 0.1 blah 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 blah. Yes. Next. 0.693 by 6. 0.112. 0.112. Clear? What happened? Value point. Sorry, next question, second one. Second one, third one, I don't know. Not a question, right on heading. Mean life or average life? 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 In bracket, Right, torque in the. You learn about torque, mean life or average life. It is the average. It is the average definition from NCERT only. It is the average of the. It is the average of the life of the all the atoms in a sample. It's average of the life of the all the atoms in a sample. Tau equal to 1 by lambda. Tau equal to, it's average life of all the atoms. Tau equal to 1 by lambda. So tau equal to 1 divided by 0.693 divided by t half. So tau equal to t half divided by 0.693. Remember this, remember this.